Welcome to an extraordinary journey into the most violent and beautiful places in our universe, stellar nurseries, where massive stars are born in cosmic spectacles. The Orion Nebula, our closest stellar nursery, spans 24 light-years and hosts thousands of stars in various stages of formation, offering us a front-row seat to cosmic creation. Stellar nurseries begin as massive clouds of cold gas and dust. Gravity gradually pulls this material inward, creating increasingly dense regions where stars will eventually ignite. As material collapses inward, it forms a rotating disk around a protostar. The incredible pressure and temperature at the center will eventually trigger nuclear fusion. When the core reaches 15 million degrees Celsius, hydrogen fusion begins. This marks the true birth of a star, as it begins to push back against gravity with intense radiation. Massive stars form in groups, their combined gravity and radiation creating shock waves that compress nearby gas, triggering the birth of even more stars in a cosmic chain reaction. The birth of a massive star happens surprisingly quickly, taking only about 100,000 years from initial collapse to fusion ignition, much faster than their smaller counterparts. Once born, massive stars immediately begin shaping their environment. Their intense radiation and stellar winds carve out massive bubbles in the surrounding nebula. The most massive stars can be up to 150 times the mass of our Sun. Their tremendous size and power make them cosmic architects, sculpting the nebula around them. Within a single stellar nursery, we can observe stars in every stage of formation, from cold, dense cores to fully formed giants, each telling part of this cosmic story. Let's explore how massive stars create powerful ripples that trigger an extraordinary chain reaction of stellar birth throughout cosmic nurseries. When a massive star ignites, it releases an enormous burst of energy, sending shock waves through the surrounding gas clouds like ripples in a cosmic pond. These shock waves compress nearby gas clouds, increasing their density. When gas becomes dense enough, gravity takes over, pulling the material inward to form new stars. One star's birth can trigger the formation of dozens more, creating a domino effect that spreads through the stellar nursery like a cosmic chain reaction. The process occurs in waves, with each generation of stars triggering the next. This can continue for millions of years until the available gas is depleted. Along the edges of these shock waves, we find strings of newly forming stars, like pearls on a cosmic necklace, each one at a different stage of development. The intense pressure at the shockwave front can increase gas density by factors of thousands, creating perfect conditions for new stars to form. When multiple shockwaves collide, they create super-compressed regions where star formation becomes even more intense and efficient. Shockwaves don't just travel in 2 dimensions. They create complex 3D patterns that shape the entire structure of the stellar nursery. In regions like the Orion Nebula, we can observe this spectacular process in action, witnessing the continuous cycle of stellar birth and its rippling effects. Before we explore these incredible cosmic storms, if you're enjoying this journey through space, hit subscribe to join our growing community of space explorers. Stellar hurricanes are enormous rotating structures spanning hundreds of light-years, creating protected zones where stars can form undisturbed. These cosmic storms have distinct layers: a dense core where stars form, a turbulent middle zone of swirling gas, and an outer shield that protects against external radiation. Within the hurricane's eye, multiple protostars can form simultaneously, protected by the surrounding rotating walls of gas and dust. The rotation creates a perfect balance of pressure and temperature, with outer regions spinning at thousands of kilometers per second. These structures can persist for millions of years, gradually transforming from chaotic storms into organized stellar nurseries. Studies show star formation rates in hurricane regions are up to 10 times higher than in regular nebulae, making them crucial engines of stellar creation. Sometimes these hurricanes can interact, creating complex networks of star-forming regions that span entire molecular clouds. Magnetic fields play a crucial role, helping to stabilize the hurricane structure and channeling material toward the forming stars at the center. As the hurricane dissipates, it leaves behind a young star cluster, having successfully protected its stellar offspring through their most vulnerable early stages. Now we'll explore one of astronomy's most fascinating discoveries: how stellar nurseries communicate across the vast reaches of space. Massive magnetic fields stretch between stellar nurseries like cosmic bridges, creating an intricate web that spans hundreds of light-years. Recent studies reveal that magnetic field strengths in different nurseries pulse in synchronized patterns, suggesting a form of cosmic coordination. When one nursery begins forming stars, Others connected by these magnetic fields often follow suit, creating waves of synchronized starbirth. Data shows that connected nurseries can trigger star formation in each other, with peak activity occurring within surprisingly similar timeframes. These magnetic connections act like cosmic telegraph wires, transmitting energy and influencing the movement of gas and dust between different regions. Magnetic fields shape the flow of material between nurseries, creating channels that help distribute the elements necessary for star formation. The synchronization can be so precise that protostars in different nurseries begin forming within just a few thousand years of each other. Like falling dominoes, star formation in one region can trigger a cascade effect, spreading through the magnetic web to distant nurseries. This cosmic web of communication ensures that star formation continues efficiently throughout our galaxy, maintaining the cycle of stellar birth and evolution. In our final section, we'll explore how stellar nurseries serve as cosmic factories, creating and distributing the essential elements that make life possible. When massive stars end their lives in spectacular supernovae, they blast heavy elements forged in their cores into space, enriching stellar nurseries with life's building blocks. Every element heavier than hydrogen and helium was created in stellar processes. These nurseries are responsible for producing carbon, nitrogen, oxygen, and other vital elements. As new generations of stars form from enriched material, they incorporate these heavy elements, creating solar systems with the chemical diversity needed for life. This cosmic recycling has been ongoing for billions of years, with each generation of stars increasing the universe's chemical complexity. The early universe contained only simple elements. Today's stellar nurseries have transformed vast regions of space into chemically rich environments. These enriched regions allow complex molecules to form, including organic compounds that serve as precursors to biological systems. New planetary systems forming in these enriched nurseries inherit a diverse chemical makeup, potentially setting the stage for life to emerge. These chemical factories aren't evenly distributed. Some regions of our galaxy are more enriched than others, creating zones more favorable for life's emergence. We are literally made of stardust, our existence tied to these stellar nurseries. Their continuing activity ensures the universe remains fertile ground for future generations.